Alright, so before we go over Chapter 8, again, just to remind you one more time of the schedule, okay? Today is the 31st, no, today is the 1st, so we're doing the lecture on Chapter 8, the rest of the period is lab. On Monday, you will do your written test for Chapter 7, and then the rest of the period will be lab. On Tuesday of next week, we'll do the written test for Chapter 8. Then I'm going to go through this review that I gave you up here. So I'm going to show you how I did both those problems. All right. Then on Wednesday of next week, we're going to have the hands-on test for chapters 6, 7, and 8. Thursday, I'll take at least part of the period to go over that test. The rest of the period will be lab. Next Friday, so a week from today, we will be getting into chapters 9 and 10. And yes, as Mr. Young, as I've said to you before, this definitely is the hardest part of the course. There's nothing that compares to this, because this is all on object orientation. You probably won't find you have much trouble with 11, 12, 13, and 14. All right. The homework for Chapter 6, the array stuff, is due by the end of the period today. All right. So is the chapter review for Chapter 6. I don't tape those. All right, but we went over them as a class yesterday. We will go over the chapter review for Chapter 8 after we get done with that today. Here were the programs that you are assigned for Chapter 7. Here are the programs you are assigned for Chapter 8. For both chapters, I did program 5 and I passed out hard copies to people. All right, so with that said, let's just get into going into Chapter 8, which starts in your book on page 305, Advanced Method Concepts. Some of this you may have heard before, but much of it will be new. All right? We haven't talked too much about passing parameters by reference and returning references. We haven't really talked too much about overloading methods. We have said nothing about ambiguous methods. We have said nothing about optional parameters. So neither one of those have yet been discussed. All right. Everything that we've done thus far, we've written stuff like this. You saw something similar to this yesterday, where we come in, we've got our main. I'm not going to write all that stuff, but somewhere in main, you've got like int x equals 7, int y equals 3. All right, int sum equals add 2, pass x, and pass y. Again, I realize if you were here yesterday, this is kind of what we did yesterday. But so we come in here and we say int add 2, int a, int b, return a plus b. You're all smart enough to know that if you look at what's on the board, if I were to do a right line right here, so if I did a right line and I said the sum is, and then I said here plus sum, that what that's going to say is the sum is 10. That shouldn't be a surprise to anyone. But I want to make sure you hear the terminology. All right, 7 and 3 right there that you see. All right, those are literal values, but these values right here, x and y that you see in gray, those are known as actual parameters. That's their actual name. Notice they've been renamed in here to a and b. Those are called formal parameters. When you write a function like this, where you pass simple data types like that, when you pass that, all right, then what happens is, literally, what gets passed is this. Does that make sense to everyone? The values get passed. All right? It's not really x and y. It's the value 7 and the value 3 that get passed. All right? if for some reason, and I can't think of a reason you'd want to do this, but if for some reason you came in here and you said this, A equals 71, B equals 29. If you did that, you shouldn't, but if you went in and in that function changed the values of A and B, it would return 100. Does that make sense to everyone? But the value of this would still be 7. The value of this would still be 3. And then we could actually put in 7 plus 3 equals 100. So you shouldn't do that, but you can. All right? Now, what if what I wanted to do was I wanted to create this sum like this, but I just wanted to say int sum, period. All right? Then what I want to do is I want to come through here and I want to call add2, but I want to pass in x, and I want to pass in y, and I want to pass in sum. In fact, let's initialize sum to 0. All right? So I'd have to add into here, int s, something like that. All right? So right now, I would come in here and I'd say something along the lines of sum equals a plus b. All right? Then return, I guess it's s, not sum. S equals a plus b, return s. There's a problem with this. I'm going to get an error message because I'm not putting the result into something. So I could literally, it'd be a little bit redundant, but I could do this. I could type in here sum equals, I could do that and it would work. But you don't code like that either. What you're going to see today, what's new, is if I want to be able to change the value of sum. I think everybody agrees with that. I want to be able to change it. So if you look on the screen, I type here ref, and I type here, I think it's ref goes first, like that. That'll work. If I do that, when I get done, it will now say the sum is 10. But if I want to be able to change the value of a simple variable in a routine, all right, there's 2 ways I could do it, and this is one way. Show you the other way in just a little bit. All right? But ref means pass the address. All right? So now it's a permanent change. If I change s, which is sum, all right, I don't even need to say this. In fact, this can now be void, and I don't even need a return statement. That'll work. Keep that in mind because that's what we're going to see in this chapter. All right? So every parameter that we've worked with so far has been referred to as a mandatory parameter. You have to pass it. What you're going to see in this chapter is not only are there mandatory parameters, but there are what are called optional parameters. And think about why you might want to use an optional parameter. I've given you examples like this before. Imagine for a second, I'm writing a program for Rankin Technical College. And I ask you to enter your first name, your last name, your address, your city, your state, your zip. Okay? I would think that probably 99% of the people who go here, if they were putting, maybe it's not that high, but if they were putting down their state, they'd put MO, right? So what I can do is I can make state an optional parameter. You don't have to put it in. I'll give you a default value for it. So if you don't put it in, it defaults to MO. You're going to see that in this chapter. So everything we did up till this point in the book has been done with mandatory parameters. Everything, which means you have to include them. All right? What we've done virtually all the time so far is we've used what are called value parameters. It's a good picture here on page 309 in the book down towards the bottom. This is pretty much what I just showed you. All right? You're calling a routine, so we're declaring a variable here called x with a value of 4. That's an actual parameter. Then we are calling display value parameter. We're passing it in x. Inside of there, we're resetting it to 777. So when you run this, I don't know if it shows the run. Yes, it does on the next page. In main, it's 4. In the other method, it's 777. When it goes back again to main, it's 4. And you might look at that and go, yeah, that's nothing but confusing. The idea is, if you're passing copies, which is a value parameter, never change the value. Period. Just don't change it. All right? And that's what the author is trying to put across to you here in this example. So what's at least somewhat new is this passing parameters by reference. I've already showed you what are typically called ref parameters. There's also output parameters, and there's parameter arrays. All right? When you declare a reference parameter, whatever it is you're going to pass in must have a value. So you initialize it to 0, or it already has a value, it doesn't matter. When you declare an output parameter, you haven't seen that yet, you will in a minute. The argument typically does not have a value. And when you create or declare a parameter array, all right, the argument does not need, or the call need not contain the original assigned values. If that doesn't make any sense, you're going to see examples of each one. All right, I already showed you the ref parameter. Notice when you use the ref parameter, you have the word ref when you pass it. You've got the word ref when you use it. All right? The reason I'm telling you that is in many other programming languages that exist, some of which I know, you have one symbol you use when you pass it. You have another symbol you use when you use it. You don't use the same symbol like they use ref here in both places. That's how they do it in this language. So this says, I'm passing an address. This says, I'm using an address. So since it's an address, any change you make is a permanent change. I can't say it any more than that. But if you look up here, we're saying ref x. And you notice how right here we gave x a value? If we just said there int x and we put a semicolon right there, so that's all it says was int x. If we tried to pass it then like this, we get an error. It has to be assigned some kind of a value, even if it's going to change. Again, not my rules, the rules of the C# language. Now you'll notice, all right, we changed it in here, but since we passed it as a ref, it's a permanent change, so when it goes back to main again, we've made the permanent change. So the reason I'm telling you this is what you have to think about is, okay, how do I want to change values? Okay, I asked you this question a long time ago. You may or may not remember it. Okay, how many values can you return from a function? Anybody remember? No. 0 or 1. 0 if it's void, otherwise 1. Now that 1 could be an array that had 100 values in it, but it's one thing. Okay? When you use ref, we could do this. I don't know why you'd do this, but we could do this in this example that I gave you. All right? So we could have said here, ref x, ref y, and ref sum. Then we would have needed to put ref here, and we would have needed to put ref here. Then if we came in and said A equals 71, B equals 29, like I did before, then it would permanently change that value to 71. It would permanently change that value to 29, so the sum right here would be 100. All right. So what I'm telling you is you can have as many ref parameters as you want. So if I'm calling a routine where I have to change the value of 8 different variables, I'm going to pass them in as refs, usually. All right. And again, I'm not saying, hey, does that make total sense? But my guess is if you go, that makes no sense, you haven't read the chapter. All right. Because Joyce Farrell does a nice job of explaining this stuff. All right, then you have an out parameter. So notice if you have an out parameter, instead of the word ref, you have the word out. All right, so let's look at how that one would look. I'm going to leave this one that I just put in here up here, but I'm going to copy it and then put it down here. All right, now I can say int x, and I can say int y, and I can say int sum, and instead of ref, out, oops, not like that, out, 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 out. Now I can come in here and do this. All right? Because what am I doing? I'm giving them values inside of here. Now when I get back to this function, this will have 71, this will have 29, this will have 100. So what's the difference between a ref and a sum? When you use ref, you have to initialize the values. When you use sum, you don't have, I'm sorry. When you use ref, you have to initialize the values. When you use out, you do not have to initialize the values. Other than that, they work pretty much the same way. Again, she runs another program in here on page 312 where she shows you exactly what's happening. So the author says here on page 313, well, how do you decide which one to use? These are guidelines. If you always have an initial value, you can't use out. Well, it's not that you can't. You should use ref. If you don't have an initial value, or you don't know whether or not you're going to have one, you use out. All right? So she gives you some stuff in here where she talks about when to use a return type and when to pass by reference. It's pretty much what I just told you. If you're not going to be changing values inside of a method, you use a return type. If you want to be changing, especially multiple values, you'll typically pass by reference, or you'll use an out. It says in Chapter 2, you learned a couple different ways to convert a string to a number. It says you can use the convert, which is the one we've basically been using, or you can use a parse. We've been using that parse inside of our isNumeric function. All right? And what it's saying in here, if you look up on the screen, is we've been doing this all along. All right? When you've been doing a convert, you've either been converting a string to a number, or you've been declaring it's an error. So you've been doing something similar to this already. Not only that, there's something that's called, there's try-parse. Again, we've looked at this stuff already. But the idea is you should be able to look at this and understand what it means. So let's quickly run through it here. This is example 8.9 and 8.10, and they're on page 315. So you come in here in main. You've got a string called entry string and an int called score. I think everybody would agree on these two lines right here that neither one of those variables is initialized. Right there. Neither one is initialized. So you put it right in there that says enter your test score. Fine. Then you do a read line, where you put it into the string. Then you attempt to parse it or convert it, and notice out score. Out means it's an out parameter, which means score was not initialized, and you can see it was not. All right. Then it tells you what you entered. All right. So if you do that, the program won't blow up even if you put in non-numeric data. So here we put in 100, so it says you entered 100. Here we put in the word perfect, so it says you entered 0. And what they're getting to in here, again, is best ways of doing data validation. All right. The one thing we haven't talked about yet is what are called parameter arrays. Okay? What if I wanted to write a simple routine that'll add up all the elements in an array? Are you with me? I just want to be able to add up all the elements in an array. So if I've got scores that all 12 of you got on the Chapter 6 written test, I want to be able to put that into an array. All right? Well, I do that, but then I realize it was yesterday, so rather than putting it in an array to figure out the average or whatever, 12 of you aren't here. Or not 12 of you, 5 of you weren't here yesterday. Well, if I give you zeros, that's going to really bring the class average down. All right? So maybe I want to be able to run it with 7 people, and then I want to be able to run it again with 5 people, and then I want to run it one more time with all 12 of you. So I want to give it a variable number of students every time I run it. One way to do that is to use what's called a params array. And what that means is I can run the same routine and give it a different number of inputs in the array every time. All right? So it says when you use params, 2 things apply. You can only have one inside of here. You can't have multiple params. All right? And it says if a method declares multiple parameters, the params qualified parameter must be the last one. So if you're going to have it in there, it must be last if you're going to have other parameters. And again, I don't know any other way to say this than this. If you don't get this, if we go over it and you don't get this, you're going to have to read the book. And you say, well, I don't have time to read the book. Tough. You're going to have to find time to read the book. I'm giving it to you kind of in generalities. You're getting it here in an hour or so. The book, you can look at it at your own pace. So when you look at this, what do we have here? We've got an array called names, and it's got 4 different people in it. All right? But then we want to call a routine called display strings. One time we want to pass it in 1 value. One time we want to pass it in 3 values. And the other time we want to pass in the array, so 4 values. So inside of the array, since we make it a params array, what should print out is Ginger for the first line. The second line should say George, Maria, and Thomas. And the third line should say Mark, Paulette, Carol, and James. And you can see that's exactly what outputs. So when you use a params array, you can give the method a variable number of parameters. They must be in an array, though, because it's called the params, whatever, array. So again, she's got a uDoIt here that uses reference parameters, and it starts in the book on page 318, and it's 318 and 319. She's got a thing called swap. And if you look at the output here, it shows you how you can swap values. There may be a reason for doing that in a program, a lot more than you'd probably think. But again, as the author does throughout the text, she tells you what she's going to tell you, she tells you, then she tells you what she told you. In other words, she gives you a prologue, she gives you the code, and then she runs it. All right. Then this, notice here, this is a new feature. This is something that was not even in the book when I taught the class a year ago, because they were using C# 6.0. So this feature that's on the bottom of page 319, and it's on 320 and 321, it is a new feature. All right. It says it allows you to return a reference from a method. It says using a ref return has restrictions, but you can only return references that C# considers okay for you to return. This is about, for what in this chapter, this is very hard because it looks different. Notice when you declare the variable, you put ref in front of the variable. So this variable, when that value gets returned, it's going to hold an address. All right? And if you say, do we have to worry about this? No, it's not on your test. But I would still take a look at the example that the author has here on page 318 and 319. She's got one of her famous, all right, I shouldn't say that. If you look in the book on page 320, she's got an example of how this can be used right here. And then she shows you, if you do that, what the output would be on the next page. All right. Now, good or bad, what the author is trying to do is show you, hey, there's 4 or 5 different ways of doing the same thing. I would suggest for you, read the chapter and say, this one's the easiest. Then use that one. All right. Page 322, they talk about overloading methods. Again, if you would please, look up on the screen here. I want to show you an example of that. All right? Don't worry right now. We're going to put the ref and the out, etc. away just for a minute. We're going to look at another example. All right? Someone. All right, I'm going to shrink this down just a bit. If you look up on the screen, please, right now, this is supposed to be in main. I'm declaring 2 integers, x and y, that I'm setting to 7 and 3, and sum that I'm setting equal to 0. Then I'm declaring 3 doubles. A, which is 8.56, B, which is 9.53, and sum 2, which is 0. Then I'm calling add 2 and passing it in 2 ints. Then I'm calling add 2 again and passing it in 2 doubles. Somebody tell me. Pretty obvious. All right. What are the differences between these 2 methods on lines 59 to 67? There's 2 differences. What are they? The return type is different, and what gets passed in here is different. The key thing is this. What gets passed into those parentheses must be different. All right, what gets passed in there, that's called the method signature. The whole thing really is the signature. But the parameter def must be different. Okay, those are overloaded methods. What do I mean? Method has the same name. They're both called add2, but what they work with are different. I could even come in here and do this. And I'd probably return A plus a blank space plus B. So if I put the sum is there or whatever, all right, then it would say not the sum is, but how about the name is? That would say the name is Jeff space Scott. The point is this. What's inside of the parens is different every time. The name of the method is the same every time. Those are overloaded methods. So they explain that here, starting on page 322. It says it involves the ability to write multiple versions of the same method. And that's what I just showed you. So notice what they have here. They've got something called display with border. All right, no big thing. But then they want to come in, bless you, and they want to be able to write it differently. So now they want to be able to pass in an int. The first time they did it, they passed in nothing. Now they're passing in an int. All right, so what is in the parentheses is different. Right? So they show an example right here. Okay, I thought what I showed you was simpler than what they showed in the book. You may or may not agree. All right. Then on page 326, says when you write a method, you could execute multiple versions of it. C# decides which one to call. This will be on your test based on that word. Overload resolution. In other words, it looks at what's in the parentheses and it says, oh, go look for one that matches that. That's what overload resolution is. Sometimes when you do this, it doesn't know which one to call. So if I call this and I've got it set up so it can take either a double or an int, remember a double is something that may have a decimal place. So if I call something, if I call my method here and I pass it in pi 3.14159, it'll automatically call that one. That should make sense because it's a double. If I pass in 7, it'll automatically call this one because that's an int. The process that it uses to do that are what are referred to as betterness rules. That's on the test. Which one would be better to call? She's got another you do it exercise here on pages 328 and 329. All right. We're almost done. We only have a few pages left. We'll take a break and then we'll look at the review. All right. So it shows you overloaded methods here. I would suggest that you take a look through that. All right. Then they talk about ambiguous methods. I've said this before. You may laugh, and honest to God, it's not meant to be funny. All right? It's IT. What you looking for? That's right next door.
All right, next one.
Yeah, sure. I've always said arguing with software is like arguing with your spouse. Doesn't matter how right you think you are, you're normally going to lose. And that's the way it is. That's the way it is in here. When you, I was more politically correct. I used to say it's like me arguing with my wife because I never win. All right? She's given up a couple times, but I never really won. So when the compiler is confused, that's where ambiguity comes in. And if something is ambiguous to the compiler, it just doesn't do it because it doesn't know what you want. So ambiguous methods says it's where the compiler cannot decide which method to use. All right? Bottom line. The only part you'll have to worry about that is when you take the written test for Chapter 8. It'll ask you what ambiguous methods are. All right. On page 332, this I've already kind of brought up to you. Optional parameters. Look on the screen if you would, please. What this says is you can take one or more of anything that you put in as parameters and give it a default value. Optional parameters mean you provide a default value. All right? Just so you know, if you've got an optional parameter like this, it must be the last one. So if you were going to make length and height optional, you'd have to say int width, int height, let's say equal 10, or whatever, or length. It wouldn't matter. So int length equal 10, something like that. If you've got one or more optional parameters, they must be last in the calling sequence. That's just a rule. Again, it's a C# rule. And that's what the author mentions here. But notice now, since this parameter is optional, this one, that means you can call it either by passing in 2 parameters or 3. If you pass in 2 parameters, length becomes 4, width becomes 6. Since there is no height, it becomes 1. When you pass in 3 parameters, length becomes 4, width becomes 6, height becomes 8. All right? There are times when this could be a godsend doing this. You know, the idea is the more things you can make in there that you can set up as optional parameters, that means you're going to be filling stuff in automatically. All right? Which means the program will run faster. She gives you a bunch of examples of this. All right? And shows you how to use it. All right? And then finally on 334, because I jumped ahead a little bit, she talks about what are referred to as unnamed arguments. It says, assume you've declared a method that looks like this. All right, so we've got what? 1, 2, 3, 4 different parameters. All right? It says here's some ways that you could call it that would be legal, and here's some ways that you could call it that would be illegal. Just take a quick look at that. If that confuses you, you can name your arguments. What does that mean? Well, look on the next page. All right? It says, assume you've declared this, you can do this. See how you've got here A, B, C, D? Here, we can do that because we're naming it so we don't even have to do it in the same order. All right? Again, do you care about this? I'd say when you're first learning, no. I just do it the way we've learned it so far. But as it says, this can make your program more self-documenting. All right? It's also easier with this disadvantage to screw it up. Much easier to screw it up when you use this. Right? And that pretty much is it for the chapter. So,